In this video, we're going to talk about the second part of section 4.1 or 3.1 in the 6th edition. And we're going to talk some more about the maximums and minimums of quadratic functions. So when we have a quadratic, sometimes it's not convenient to complete the square. And you saw when we did one, when we got into fractions or if we had decimals, it wouldn't be a really easy thing to do. So there is a way that we can look at find the vertex without doing the complete the square. And to look at that, I want to look at a graph of here's a pretty simple quadratic, right? And the zeros for this, fall right in here somewhere, and we don't really know, from the graph, of course, we can't really tell what they are, but we have a formula for it. So if you remember, the formula is the quadratic formula. So that formula for each of those is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I could also write that in two parts. Okay, so I could look at it as negative b over 2a, and then we have this plus or minus this thing, right? This square root of b squared minus 4ac over 2a, right? So that means that here we have the middle, right? The vertex, and I've got plus something and minus something. And they're the same because this is symmetrical. So this x value here that goes through the vertex has to be negative b over 2a. Because then to get the zeros, I would add b square root of b squared minus 4ac over 2a to get this one, and I would subtract it to get this one. But that leaves that negative b over 2a right in the middle. Okay, so this right here is my vertex. Simple, huh? That's the x part of the vertex. Now, how do we find the y part? Well, we figure out the x part and then we just plug it into the equation. So the way the vertex works is the x value is negative b over 2a. The y value is f of negative b over 2a. Okay, so we just plug it in. All right, so let's try some out. So here's a function. It would be really easy to complete the square on this, but just as easy to say that the x value of the vertex is going to be negative b. So this is a 4, not a negative 4. So that'd be negative 4 over 2 times a, and a is 1, so that would be just 2. So we simplify that, and x is negative 2. The y part of the vertex would be to plug in negative 2. So we would plug in negative 2. And we get 4 plus negative 8 equals negative 8. Okay, so this this function is a positive, has a positive number at the beginning, right? So this opens up, so we're looking at a minimum. Okay, so there's a minimum at x equals negative 2, and the minimum is negative 8. Okay, here's the function, and we want to know where is there a minimum. So that would be at the vertex, and that would be at the x part of the vertex. So that would be negative b, so that would be negative 1.2, so that's positive 1.2 over 2 times 1. So, since you don't have a calculator and you won't be doing it, let me show you how I would simplify this so that I don't mix up where the decimal is. I would just multiply the top and bottom by 10. So we have, multiply that by 10, it becomes 12. Multiply the bottom by 10, and we get 20. So we have 12 over 20. 4 goes into the top 3 times. 4 goes into the bottom 5 times. So my minimum occurs at 3/5. Finding out what the minimum is takes a little more math, a little bit harder without a calculator. Since I've got decimals in my original, let me change this to decimals. So 3/5 would be the same as 6/10. So we can plug it in. So 0.6 squared, so 6 squared would be 36, and there's 2 decimal places, so that would be 0.36. Well, 12 times 6 is 72, and there'd be 2 decimal places. So 0.36 minus 0.72 is going to be negative 0.36 plus 16. So we're going to have 15.64 if I take away that 0.36. Okay, so this is the minimum value. So story problems that are more realistic are are often easy to do with this little formula, easier than if we had to complete the square or something. You know, it turns out that lots of things in the real world end up with kind of a quadratic formula that describes them, that models them. We already saw how gravity, the pull of gravity, makes a quadratic when we're trying to describe height. And this is a situation where we have a drug. So, of course, when you first take the drug, you wouldn't have any of the drug in your bloodstream. And as you swallow it and it dissolves and it gets into your bloodstream, it rises. But at a certain point, it reaches a peak, and then it starts getting out of your bloodstream. And so by checking many people, they're able to get a formula that pretty closely approximates how much of the drug is in your bloodstream after t minutes. So this is a function in t, but t is working just like the x. So when we are trying to find the vertex again, we would be finding the t value instead of x, right? Because that's the dependent variable that we're choosing. Now, if you notice, this is our t squared, right? So this is not in our standard order. So if we were to write this in our standard order, we would see that we have a negative t squared, right? So that would mean that it's an upside down parabola, right? Of course, we start with 0 in our bloodstream. It goes up. At some point, it reaches a maximum. goes back down. At some point, it's out of your blood system. Okay, so our A is negative 0.0002. Our B is 0.06. Okay, so T in our formula, which is when, right? This is saying when is the maximum serum reached? Well, it's when T is equal to negative B over 2A. So I've got negative B, so 0.06 over 2 times A. So that's going to be a negative number. And I've got 2 times this number. So that's going to be 0.0004. Don't make very good points here with this. Alright, so negative and negative, that's going to make a positive. I'm going to multiply the top and the bottom by 1,000. Actually, 10,000. So we're moving it over 4 places. So I have a 4 on the bottom. When I move the top over 4 places, I get a 600 on the top. And when I take 600 divided by 4, well, half of 600 would be 300, and half of that would be 150. So 150 minutes, right? After 150 minutes, the drug is at its maximum level in your bloodstream. Now, what would that be? What would that maximum level be? Well, I'd probably need a calculator for that one. I mean, I could do it, but it would be, I probably wouldn't ask you to do that problem on a test just because there would be a lot of figuring to do. So if you wanted to figure it out on homework and you needed that, you could go ahead and feel free to use a calculator for that. Okay, so here is the quiz question for this video. I want you to find where there is a maximum value in the function f of x equals negative 0.03 x squared plus 6x minus 400. Alright, so I didn't ask you for the maximum value. I asked you where is there a maximum value. So figure that out and put it into the quiz question on Canvas.